Sir, thank you for being here. Over to you for some opening comments.
Thank you, and I appreciate the opportunity to be here and share the stage with my colleagues. As Brian stated, it's all about the data. So I'm going to start there because it is all about the data. And I think, and this is an unprecedented time that we're in today. We're at the convergence of data and AI capabilities. And what we're seeing today is unprecedented challenges as well as unparalleled opportunities. And that's within that space is where we want to reside. How do we take advantage of the opportunity that we're seeing today with data and AI and the capabilities that we need to bring to the battlefield? And the Marine Corps may be known to be aggressive and being innovative, but the Coast Guard does great work too, because the battlefield does include waters. And so you guys are doing some great innovative stuff on top of the water. And so innovation takes place across the landscape. The traditional battlefield is no longer just the earth, it's the water, it's even space today. So we have to look at it from all these different dimensions of how we're going to develop and integrate within that space. And from a service perspective, we're looking at it holistically. We're not just looking at AI as a focal point, a single focal point. It's a part of the wider ecosystem of disciplines that we need to understand as a service. How do we integrate across the service? And we're looking at not just data, we're not just AI, but we're looking at the foundation of what I feel data and AI ride, which is information and knowledge management. That group is foundational in how we capture, secure, store, and share data, deriving insights from information and really providing that decision support to commanders. That's incredible, that's important. That decision support for commanders for the battlefield, we're getting that data. How do we then address that information at real time, at the edge, and utilize capabilities there to expand and to continue to increase and to integrate the work that we're doing across the service. So we're looking at it holistically, and I like to go back to one of my favorite books is by an author, Michael Hammer, Agenda, and he talks about re-engineering. That's a term he coined back in the 80s during the computer revolution, the computer age, the revolution there, and he looked at it differently from a business perspective of how businesses that survived that computer age were the one that re-engineered how they did business versus added on to existing processes. And that's where that short-sightedness can come in. If I just tack it on, I can make it work. It's not always the same. And so we have to take a different mentality, a different mindset. It's a cultural shift. It's getting the right talent in the room. If understanding business processes, is understanding what is the mission of the organization and what is the strategy that we wish to implement, tie all those together to ensure that we're delivering the right capability. Is that AIable? Maybe, maybe not. Maybe it's just a process that we need to look at and update that process with some machine learning. There are different things. In order to do that, we have to go backwards in order to propel ourselves forward. So that's the mindset we're taking. We're not trying to fight harder. We want to fight smarter. And that's the way the Marine Corps intends to go.
All right, well, thank you very much. Next, we have Mr. Brendan Sang, who is SHIELD's AI co-founder and president and chief growth officer. Previous, Brandon served as Navy SEAL for 7 years and surface warfare officer aboard the USS Pearl Harbor. He founded SHIELD AI with the mission to protect service members and civilians with intelligence systems, driven by his firsthand experience during deployments to Afghanistan, the Pacific Theater, and the Arabian Gulf. At SHIELD AI, he leads business development, corporate development, strategy marketing, and government relations. Thank you for being here, Brandon. Over to you.
Awesome, thank you so much. And just aside from our mission, SHIELD AI, in pursuit of that mission, we're building the world's best AI pilot. Easiest way to think about an AI pilot is self-driving technology for aviation. Why is that important? It enables aircraft to operate without GPS, without communications, enables the concept of teaming. Wanted actually just to first level set on like what AI is, because it gets thrown around a lot. And I think if you ask people in the industry, we think of it as a tool, right? It's a tool, it's a technology, and what really, really matters is the end product, the solution that you are gonna build with said tool, right? I think about the internet the same way. What an incredible tool, an incredible technology, connected the world, but you look at the products that have been made on the back of the internet, right? Whether it's massive companies, Google, Uber, Facebook, Instagram, you name it. The social media one comes to mind. Lots of amazing value in companies were built on the back of the internet. The same will be true of AI, and it's an incredibly powerful tool and technology. So what is it at its core and how we think about it? It's a system's ability to perceive the world, its world, to think about the world and take action on the world. That AI could live in the form of a chatbot, ChatGPT, right? It's thinking, it's perceiving what you're writing to it, it's thinking about it, and it's spitting out an output. It could be a self-driving car that has different sensors, that it's perceiving its world, building a map of its world, thinking about what it should do, and then taking action on the world. Or in Shield AI's case, it can be an autonomous F-16 that is perceiving its world, thinking about its world, and then taking action on the world. And this is a fundamentally powerful technology as we think about the military. It's a force-changing technology, right? You've heard Secretary Mattis talk about it changing the character of warfare, which every SecDef since has said something similar. You've heard Vladimir Putin say he who controls AI will rule the world. You've heard Chairman Xi say, China intends to lead the world in AI by 2025. It's because it's such a powerful technology that is a force-changing technology as we think about it as it relates to military aspects. So what do I mean by a force-changing technology? I'll draw an analogy to a couple technologies that I think have been force-changing in the spirit of this conference. I'll make them naval ones. Naval aviation, force-changing technology. We got away from battleships, rethought our force structures, eventually came to this model of the carrier strike group. But that is because the technology, air superiority, naval aviation, was so fundamentally powerful as a strike capability, as a deterrence capability. The US military rightfully figured out that we need to change the way that we fight. Another one that I would put up there as equally game-changing, submarines, right? A fundamentally different technology that changed the way we fought, changed the way we organized our forces, et cetera. AI is going to do the same thing, right? Especially as we think about AI as it applies to the maneuver of unmanned systems, even to the maneuver of crewed systems. Back in 2015, I asked myself, what does the military of 2035 look like, and what does the role AI play? I decided, and along with other folks that were thinking about this, Bob Work comes to mind, that the military should be, or every military asset should be commanded, maneuvered, piloted by artificial intelligence. And why is this a force-changing technology? Everything from our F-35s, uncrewed F-35s to submarines, uncrewed submarines to ships, every aspect, there should be a command element, a maneuver aspect that AI plays in that role, whether it's a decision aid or whether it's actually piloting the aircraft in the case of Shield AI. Okay, so why does this change the force? For the first time in human history, you are no longer limited by the personnel that you have. And in a massive way, you're no longer limited by the budget. I caveat that. There's still, budget still matters. But the way that the world is changing, it matters much, much less. And so what's this mean? Small militaries, small countries can have outsized effect in deterrence, in national security, on the battlefield. There is no reason why a country with a $50 billion budget can't have the same, force effect as something like the United States, which has an $800 billion budget. And that's something that I think is so critical for our leaders to start thinking about because it's happening and it's going to happen fast. Okay, so what do I mean? Instead of buying a $5 billion aircraft carrier, you can now buy 1 million drones for $50,000, right? And those drones can be powered, maneuvered by AI, applied with massive effect onto the battlefield in any circumstance that you can think about. And that's what our leaders have to start thinking about is what is the right force structure. The Air Force talks about a high-low force, hybrid architecture, which I think makes a lot of sense. where you have exquisite assets that are highly centralized, still necessary for specific missions, but you have a massive massive fleet of low-cost, inexpensive UAS, UUVs, USVs that are powered and maneuvered by artificial intelligence. And it's good to see, from my vantage point, you see leaders who are thinking about it this way. I was with the AFCENT commanding general at the beginning of January. He said, look, I don't care about 1,000 drones. I don't care about 10,000 drones or 50,000 drones. This is about hundreds of thousands, if not millions, of drones on the battlefield. And that's the direction that we have to move as the United States, and along with our allies and our partners. The last analogy that I'll make, and as I think about it, it's not so different than the United States' move to mobile computing. And I'll just highlight this analogy. The US, we went from desktop computers to laptop computers to mobile computers. And actually the amount went from, you could say a few in the grand scheme of things, desktop computers, to many mobile computers to ubiquitous, many laptop computers to ubiquitous mobile computers. The military analogy is prior to 9/11, we fought with very expensive, very few exquisite assets: aircraft carriers, fighter jets, helicopters, very few of them. From 2001 to 2020, we really learned to fight with remotely piloted aircraft. These are our drones, the MQ-9, the MQ-1, MQ-4, fantastic aircraft. This world that we're moving to, and so that's our laptop computer. And then the world that we're moving to is this world of intelligent, affordable mass. That is our mobile computer. It will become ubiquitous, right? And essentially, the way that we think about our aircraft, they're really just flying computers. That's how, flying computers with sensors. And those things are trained to do specific mission sets, no different than you or I have been, to the military members and the veterans of the room. We're trained to do specific mission sets. That's the curve that we're on. What's really, really interesting is in the same way that you saw countries, whether it was India, whether it was South America, Africa, even European countries, they skipped desktop computers. They skipped laptop computers. They went straight to mobile computing and built out their entire infrastructures around a mobile computing infrastructure. I work with countries every single day, working with their militaries, trying to help them, our allies, our partners, trying to help them solve their national security problems. And they're going straight to the answer, which is intelligent, affordable mass. And so the United States, we have to move with them, but in a really strange way, you can see them outpacing us in many ways as they start to adopt this technology. It's something that, look, if our partners, our close allies are doing it, we should be there right alongside them, encouraging them to get there as we get there as the United States.
All right, thank you, Brandon. Finally, we have Dr. Glenn Henshaw, who is a senior scientist for autonomous and robotic systems at the Naval Research Laboratory. Glenn, thank you for being here. Over to you.
So I've been at NRL for 20 years. I cut my teeth on space robotics. I'm the lead roboticist on a DARPA program called RSGS, which is going to be the first robotic satellite mechanic when it launches in 2026. It has no AI on it. And that's an interesting insight into how AI can be applied and what some of its limitations are. So we did not use any AI technologies on our space robot because we didn't understand how to rigorously validate its performance, whereas we have sort of traditional controls and path planning and other techniques that have been derived over the decades for use on robots, that we have the mathematical tools that allow us to guarantee what the performance is going to be, and then sort of insert that into a standard systems engineering practice where you can put together a large, complicated system and have some confidence that it's going to work the way you want it to when it's done. And I think if I was going to give one message to the group, think I want to emphasize, we know how to build machine learning systems that can do incredible things, and yet we don't understand how they do those things. And that's a really interesting place for a researcher to be. ChatGPT, which took the world by storm a couple years ago, I think surprised folks in the industry maybe as much or more as people outside the industry, because it seemed to have these emergent capabilities that I don't think anybody expected other than maybe OpenAI. It also notably took a team of a couple of hundred engineers to build, and I don't know exactly what the cost was, but the numbers that I've heard floated were about $50 million just to rent the GPU time to train it, which is a project that's larger than a service lab is really set up to pull off, right? So I think AI comes in a couple of flavors. I think it's always going to be the case that really cutting edge AI is going to take all of the data and all of the computing that we have. And that's going to be very expensive, and it's going to be in the hands of a few people. But I think that there are applications of AI that don't require that much cost and expense. And we're going to see maybe less capable, but much more numerous applications of AI in drones, in cyber, in lots of places. And that's a fundamentally democratic technology, right? In a way that a lot of the other standoff technologies have not been, right? You can't build a nuclear weapons program in your basement, but you can build an AI in your basement, and you can put it on drones in your basement, and you can see these things coming out of places where it's very hard to track. As a consequence, I've completely given up on trying to predict the future. Every day I get up and I'm surprised. And again, that's a really exciting place to be as a researcher. So I think where we're trying to position ourselves at NRL, we often say we're a coin-operated lab. We're a Navy working capital fund. We don't have appropriated money from Congress. But I think we're trying to figure out how we can take what's coming out of the very large, very well-resourced Silicon Valley companies and apply that technology to areas that the Navy is interested in, but for which a commercial market may not exist that will cause OpenAI to go after it. But we're also really trying to go after how do we come to grips with the fact that we have these technologies that in many cases can outperform humans, and yet we don't understand exactly how they work. How do we build trust in those systems? And I think the answer to that is we have to completely change the organization of the DoD. The way that we build trust, I never served, but my dad was a first sergeant in the Marine Corps, and he trained a lot of Marine recruits. And I think he would say much the same thing that I'm saying about AI, about a Marine recruit, which is you have no idea how a Marine recruit makes decisions. And what we've done is build a system where we can take people coming in that we recruit and we train them. And we don't necessarily trust the individual when they walk in the door. We trust the system to create a Marine, right? And we have ways of evaluating Marines. And if we don't like the outcome of that evaluation, we have ways of going back and retraining and remediating. And then we embed them in a system that allows the entire system to be trustworthy. So we don't levy the requirement to be trustworthy entirely on the individual. We build a whole structure, and we think that the structure is trustworthy. And I think that's the way that we're going to have to reorganize ourselves around AI as well. We're going to have to embed AI in a structure that we trust and not levy the requirements to be trustworthy entirely on the AI itself.
All right, well, thank you. Some great opening comments from our panelists here, and we have a number of common themes that I think we can build on here as we move our conversation forward. Since the theme of this is kind of the future of the AI Battlespace and how we're thinking about how this technology is going to transform and everything, which we've all alluded to in some respect. Let's start there with where we are now. I've often used this construct that, it's just a mental thing of, and this probably applies to any new tech tool or technology, which is when something new comes in, 90% of where I apply it is going to be on stuff that I do now. I'm just going to do it better or more effectively, or something I will do, though, what I am doing now, but with this tool, and I will incorporate it somehow. About 9% will be things that I couldn't do before, but I am now enabled to do because this tool allows me to do something I wasn't able to do before. And then 1% being this transformative, wow, I never even thought I could do something like that. I only dreamed of this, and it completely transforms the way that I think about it. A rough rubric to think about, how a really changing technology can kind of shape things. And again, you kind of alluded, I think, into your comments as a group, that type of opportunity and the way we can be thinking about it. So using that as kind of a little bit of a rubric, looking at kind of where you are currently in your organization, any thoughts on kind of what you're doing or what your organization is doing to kind of enable that, hey, help us do what we do now better, but with some thought about and how are we thinking about that transformative thing, that things are really changing? How are we looking or enabling our organization to be able to take advantage of that? And the reason I say that is you're all in very different places, and you're sort of approaching this problem from a different perspective. But having watched different organizations, right, they have to tackle this differently based on the resources they have and the equipment and the personnel that they have available. So I'm just kind of curious to hear from you generally on that topic about how your organizations are poising themselves to be able to move into this. And
Sure. And I'll actually start with what you were saying is how does it fundamentally change things? There's no reason why a platoon-sized element, 16 people, won't have the combat power of a carrier strike group. And that's like a really powerful statement if you start to wrap your head around it in terms of what is actually possible to command that many assets, to command that much firepower with a very, very, very small team, which is done today with 5,000 people going down to 16. That is what is going to happen in the near future. When I think about where we are today, it's about scaling out that technology, right? We're giving a single person command of 4 aircraft, eventually 8 aircraft, and it's really to the point of building trust. You're just working with them so they can understand those work cycles, those feedback cycles, so they're actually getting familiar with the system, what it can't do, and really, really interacting with it. But it's not a question of, is this possible, right? Can we put AI on different things and make them maneuver? It's yes. Right now it's a game of scaling and how quickly we want to scale and how quickly we want to move out to that end state, because it's a very, very obvious end state that you can get to with effort, with resources, with people who are hardworking, smart, and focused on that end objective.
all right, anyone else want to chime
So
in there?
I'll go next and I'll jump on that. So that's a great question, because as we look at it, and I look at of course from a strategic operation and tactical lens, but I reside at the strategic side. Mm-hmm. So how do I look at it from a strategic side for the implementation of this new capability, and how do we account for it, how do we address it or integrate it as we move forward? And I mean, that to me, I think that's what kind of keeps me up at night as we look at the landscape, is how do we move this forward? Because we have to move it forward from multiple different lenses at the same time. We have to look at it from a talent. Do we have all the talent available today? And if not, how do we set in motion to get the talent either from commercially procuring talent or developing talent in-house? And so from a talent perspective, we're looking at that. How do we develop that talent? What is the future state of the Marine Corps? How do we digitally transform the Marine Corps to get to that end state of data centricity and ubiquitous implementation of technology and capabilities at the end of the rainbow, so to speak. So from a strategic point of view, we have to look at it from okay, so here's one path, we have to move this path forward. Then it's culture. We have to make sure that we get the culture right, because yes, I can buy this technology, but culturally, if we're not embracing the technology, if we don't have the training and understanding, then I'm just have another capability that's just another brick or a layer that's sitting there that's not being maximized. Mm-hmm. So we have to look at it from that perspective as well. So when we look at how AI within the service and how we are integrating and moving forward, all these things matter. So, what are the disciplines out there? What are the different billets out there within the Marine Corps that uses, touches, understands AI? We need to identify, we need to understand that, because that's a part of that workforce that we need to make sure that we can put our hands on, and then identify that workforce to expand their knowledge base to be ready for that AI capability that we bring in later on. And of course, there's the tools of, now we're just using, are we buying AI systems back from manufacturers saying, hey, you're providing us this equipment, we want this equipment to do something, or we want this equipment to have this type of capability, and it may be a full-on AI solution, it may not be, but we have to understand that, which means that we have to do some kind of assessment of our system to understand that. So all these are taking place all at the same time, that we have to kind of keep our eye on to ensure that we are moving forward, because at the end of the day, we want to be responsible about the AI that we're implementing, and we want to put in guardrails to make sure that we are implementing this capability in the right manner. We're talking about centralized governance and decentralized implementation, and that's the method we want. We want this capability to be able. We want our Marines, civilian and uniformed Marines, to engage in AI, and contractors that support the Marine Corps to provide that support and engage from all of these echelons to make sure that we move this capability across the line at the same time. I think that's, from a vision perspective, that's the only way I see this truly integrated and working as a service moving forward.
And I feel like, Brandon was talking about scale, but a little bit about what Colin's talking about is you got to have speed in there as well. I think in the future, I believe in the future of the AI battle space, there is going to be a speed element, and the whether our adversaries or us are able to adapt faster in a scenario is what is going to matter. And we've never had a more elegant space to play and figure this out and experiment than artificial intelligence and the technology that comes along with it. What is our metric for success or really as we prepare to fight our adversaries in this more algorithmic warfare future? What is our metric for success? And I think that one of the things that you need to look at is when you create a piece of data, whether that's from a sensor or wherever it happens to be from, and then there is an effect that happens from that, what was the time distance there? And how fast could you make that effect happen? I think that is going to come into play. And that's not just the speed of an aircraft. That happens to be our networks, the people running it, the C2, the decision making, everything that is in between, from the creation of that piece of data all the way to the effect that occurred. Whoever is going to be able to do that fastest and then adapt and do it faster the next day and the next day and the next day is going to win. And I think we in the U.S. military are obsessed with the night after scenario. But there's a night after scenario after every single night. And the adversary that can adapt every single night faster than the opponent is going to be the winner. And I have, what keeps me up at night is that our structure, our C2, our culture, our networks, our IT, even all the way integrated into our weapon systems, there's enough of a barrier, whether that happens to be technologically, bureaucratic, whatever, that makes that time distance, so great that that's a big concern, I think, in warfare. So scale is massively important. I think speed's important as well.
And I'd like to follow up on that. One of the unique strengths of the U.S. military is the amount of individual initiative we push down, as far as we can push it down into the ranks. And I think we've got to give end user warfighters, I don't know of a better word for that, the folks who are actually using these systems, the ability to experiment and modify them, which is a mindset that we have not currently bought into, right? We want to give them a tool that has been well vetted and that we understand. And that takes away some individual initiative with someone who is using a system that is intelligent in and of itself. If we can change the way that it operates on the battlefield, we give them the opportunity to adapt much faster than anybody else can. And I'd like to give you maybe an example that comes from the work of my group at NRL. So we build spacecraft mostly. The way that spacecraft are tasked today is a very manual process. So we've got a large spacecraft. It's going to go overhead a couple of times a day. You've got a group on the ground that's figuring out what you want that spacecraft to look at. It takes imagery or other kinds of data. It downloads all of that data to the ground, and then it's analyzed mostly by human beings using computer tools. And as a consequence, the tempo at which you can get data off that spacecraft, is hours, hopefully. But imagine that you now have the ability to put enough smarts on that spacecraft so that it can tell when it's taken a picture of what you asked it to take a picture of, and it knows whether it's there or not. So you're going to fly over some naval base, and it's expecting to find an aircraft carrier, and it knows whether there's an aircraft carrier there or not. You can now imagine if it doesn't see an aircraft carrier, it tasks itself to try to find where that carrier went. Right? Now, that would require downloading that data to the ground, looking at it, having some people scratch their heads, giving it new tasking, and you find the carrier eventually after, maybe if you're lucky, the next pass. It might take a couple of passes. Now you can find it on exactly the same pass that you noticed that it was gone. So that data becomes actionable much more quickly. And now push that to the next step. We're looking at spacecraft that fly in what's called the VLEO regime, very low Earth orbit. They don't need to be as big because they're closer to the ground. And if they have the ability to task themselves, you can imagine flying many of them for the cost that you would fly one classic asset. What you're doing is turning spacecraft into a tactical device instead of a strategic device. And you could imagine, in not the too far distant future, the spacecraft is cognizant of a conflict going on. It sees things that the commander on the ground needs to know that the commander on the ground doesn't know that he needs to know about, and pings his device as it goes overhead and says, hey, there's an enemy whatever over the next hill. You didn't know that, but now you do. That's happening in seconds instead of hours.
Well, I was jumping off of that, I was thinking that it wouldn't be a panel on AI if it didn't make some quote to some sci-fi movie or something. So this kind of reminds me of the classic Star Trek with the Borg, right? They'd be attacking the Borg, and the classic line, which is, they've adapted, right? Their new tactic was effective for moments, and the Borg quickly adapted, and that idea of the very rapid adaptation being necessary, and more importantly, enabling the people to be able to do that adaptation. I think that some of the themes here struck that idea that we're trying to get more comfortable with that. I think probably some of our experiences, we've seen adaptation happen locally, say on the battlefield or in the local environments, but sometimes that we get in our own way with whether the structures that we put in place that can be hindering that. So kind of leaping off of that, I would like to get your thoughts, thinking about moving forward, and again, kind of where we are today. If there's something you could like wave a magic wand and either fix or create, in other words, what's kind of, we alluded to the challenges, there's lots of challenges, and got it, right? We're people, we love tackling challenges and working through them and creating solutions. But if there's one thing that you could sort of like wave your hand and like immediately have fixed or understand, what would that be? Like, what do you kind of perceive as one of the biggest issues?
I'd love to know how LLMs actually work, if I could wave my hand. I don't think that's going to happen. No, I think if I could wave my magic wand and create one capability, one of the ideas that we're really excited about, there's a kind of machine learning called reinforcement learning, and I won't go into the details, although I could get very nerdy about it. But it's the kind of machine learning that you use to control a robot or other device, and a fighter aircraft, an autonomous ship, and an autonomous submarine. It's taking the place of the pilot or the operator. Right now, in order to use reinforcement learning to control a complicated device like an aircraft, we have to do it in simulation. typically, because it takes so much data that you can't fly the F-16 enough while you're training the reinforcement learning. Plus, it's going to crash a lot, and that's typically bad, right? So we do it in simulation. But even the simulation takes a long time. Running simulations that are accurate enough that you can trust the results is very hard. And so you're typically talking weeks to months of simulation time to get a policy that you would feel comfortable putting on an aircraft or putting on, a ship or another kind of autonomous system. It turns out that to a great extent that changed in the last year or two. NVIDIA has released new software tooling that runs on GPUs that will allow you to run many, many, many orders of magnitude more simulations at a time than you could in 2021. And as a consequence, we are now able to train. We've got quadruped robots. You've seen, Spot Minis and other robots on YouTube. We can train those robots to walk over lunch, literally. We'll push the train button, we'll go get some pizza, we'll come back in an hour, and the robot will be walking around the room. If you take that to its logical extreme, you could imagine having a system that you can put on a Humvee or on a ship or in a tank or wherever you need it, and it has the ability to retrain these small systems very quickly. And it can run so many simulations that it can explore a huge variety of scenarios and tell you exactly how those scenarios are going to play out. So it becomes not only a way for the end user to fine-tune the operation of their system, but it also becomes sort of a organically owned battle decision aid, right? This is the best way to use these systems in this particular tactical scenario. That's a capability that we have not yet developed and pushed to the warfighter. And if I could wave a magic wand, that would be it. The ability to retrain your systems to respond to the exact tactical problem you're facing right now.
Yeah, I think the whole concept of one-shot learning and being able to speed up the training and learning process has always been a key item of interest. And even that idea of, hey, when one minor thing changes in the parameter set, you don't want to have to retrain that whole thing. And so that's been a long sort of process that academics and everyone is trying to figure out, is how to make systems more robust and more flexible. Curious, anyone else? What would you fix?
And actually, I just want to piggyback just on the example he was giving, because it's something that Shield AI is very, very familiar with. When we started the DARPA Alpha Dogfight program, we would accumulate about 30 years of flight experience and simulation in about 3 months, which is like pretty amazing. 30 years, that would normally take a pilot 30 years of constant flying. Every single day for 30 years, we're able to accumulate that in 3 months. By the end of the program, we're accumulating 30 years of flight experience in 3 days, right? And these pilots, these AI pilots, they learn slower than, or they learn differently, I'll say. They don't learn slower. They learn differently than a human pilot. And it's like, you can bring that down. It's a matter of how much you want to invest in it and how much you want to resource allocate. No reason you can't get to 30 years of flight experience in 3 seconds. So just via parallel simulation, parallel computing. And it's just a matter of ROI in terms of like what you're actually trying to drive from it. But if you it's a very, very powerful thing to think about in terms of like, that was available 2 years ago, right? In terms of where we are, when I think about where we are today, it's much further along, and it's really just a limitation of resources. Which brings me to the wave your magic wand thing. I think it's the biggest challenge to getting to this paradigm is the acquisition system. It's not the technology, it's resource allocation. The government is notoriously bad at resource allocation. And so when I think if you could just wave a magic wand, if you cut the bottom 10% of programs and reallocated that to a new hybrid force structure movement, that's what I think is pretty interesting, right? And I think a lot of people have been, Replicator's a nice first step, and I'm very bullish about it, and it's exciting. But when I think about it, right, $200 million in the budget for it, that's a drop in the bucket in the grand scheme of things. I'm optimistic in terms of what the team will be able to do with that money to move the needle, but that is, I think everybody can say, this is the direction that we want to move towards. We should move there faster, because speed matters.
So I'm gonna piggyback off Brandon and kind of make it about the acquisition process. And I think if I did have that magic wand, I think I would like to be able to adopt a more robust process, probably more like what industry process on this side of the fence, so that we can really weaponize the development from the development of conception to purchase and implementation, so that we can make that a true rapid adoption process to get in the right capabilities in the hands of Marines at the speed of need, without having to having to worry about all these steps that we need to go through. And again, just looking at it from a strictly, this is what we need, and this is a fixable process as we are, and I know we're moving towards a lot of that. It's really understanding how to get there, but that's the process I want to fix today, so that we can not have to deal with that piece of it anymore and focus on the modernization, the development of the core from a pure sense, and not have to deal with the bureaucratic hurdles that we have to go through, for day in and day out. And it is there for a purpose, I get it, but nonetheless, that's a process. If we could fix, I would say, let's fix that process. You want that gear, you want it over here, you want it when, boom, there it is, it happens. And you can, of course, the training and everything involved, you now have a process where it's maybe months instead of years to that process.
Yeah, I think it feels like we had sort of a foretaste with that issue when dealing with computers and just networking, and we see the speed at which that technology changes, which is kind of glacial when you look at the technology we're talking about now, but how the system in general has had difficulty in incorporating, a modernization of this capability, something as simple, quote unquote, as computers. And now we're talking about an even sort of more rapid turn. And the stress on the system is becoming more apparent as we have these long lead lines and systems that need to happen, and things are developing and changing so rapidly. So it's a big issue. Captain?
I'm not going to deviate too far from this. I'll just keep this train going. But if I had a wand, I would wave it, and this is how I'm going to get three things into one. But I would take away the headaches of my team, and the majority of the headaches and frustration that often happens would be, a desire for rapid acquisition. And some of these problems are because we're just not good at, as a program office, we're not good at doing the things that other people are good at. So there's probably fast ways to do it, but I don't know them. My team doesn't seem to. Rapid acquisitions, hiring civilian employees, the authority to operate process. Those are very time-consuming things that my team goes through. There's many hurdles along each one of those pathways, and that's probably gives more headaches than anything else. Yeah.
And yet to pile on more, there's a reason why we do acquisitions the way we do, and it's because the systems that we acquired historically that really changed the needle were large, right? And it takes a long time to buy an aircraft carrier, and it should, because that's a very complicated, very expensive system. It's not something that you're going to show up and put in your U-Haul and carry home the next day, right? This is a technology that is going to be as groundbreaking as the invention of gunpowder, right? And it's going to be carried in much the same way that a rifle is carried. But rifles haven't changed that much in the last 100 years, right? Bullets still look the same as they did 100 years ago, and so the acquisition process by which we buy bullets now can look largely the same as it does these other large acquisition programs, because we're buying the same thing every day, right? An M16 looks like, this year looks like an M16 of 10 years ago, more or less. That's not true anymore. These systems are going to look very different 6 months from now than they do today. And if we take 6 months to procure them, we're going to be hopelessly behind.
So I have a caveat. I'd like to jump on that.
Absolutely.
And you said something that I just want to kind of emphasize. The difference between systems and purchasing capabilities. And we're navigating that. Like a system, get it, understand it, capability is something totally different. And we need to wrap our minds around capabilities a lot more faster to put into the system and get in the system itself. I just wanted to put stop that.
All right. Well, I think we have about 7 minutes left here. So if we have any questions from the audience, I think we have a microphone, at least in the center. If you have any questions, let's see what we can do here with the time we've got left. Yes, sir.
Sydney Freeberg from Breaking Defense. Interesting, you had a bunch of talk to the two of you on the end, Mr. Singh and Mr. Robert Henshaw in particular. Both of you mentioned the fact that we need tremendous amounts of data to train these AIs. That, you're talking about, however fast you're doing it, you're talking about 30 years of simulated flight, constant flight. We're talking about huge amounts of data. And people are talking about how the large language models are running out of data on the internet to train their models. I'm pretty sure that a human F-16 pilot does not take 30 years of continuous flight before they learn how not to crash. So clearly the human brain is doing something very different than these AI machine learning neural net models. So is there a way, besides just let's simulate everything and hope our synthetic data is actually more or less accurate to the real world, is there a way to get another generation of AI, DARPA talks about this sometimes, that doesn't require such brute force learning? I mean, currently the equivalent of a toddler that takes until they're 50 to learn how to speak a sentence. And clearly the human brain's taking a shortcut there.
Yeah, that's a really good question. And it goes to one of the core sort of debates in the AI research community. And most researchers, it really hurts to say this, but it's true, which is things that scale almost always in the long run beat things that don't. And what scales is we can collect more data and throw more processing at the problem. And historically, that's outperformed sort of more bespoke techniques. Now, is that always going to be true? I don't know. But to date, that has proven to be true far more often than not in the machine learning community. So I'm not saying that the techniques out there don't exist by which you could sort of improve the data efficiency of systems. And I think for some applications, and particularly maybe military applications where we don't have as much data, those will prove to be important. But for something like a large language model, I actually don't think that that's going to be the way that the community goes.
I would just say, when you use the word, you hope that it works out. It's not hope. It's very engineering, principled, driven science in terms of actually validating it, testing it, making sure it works as you engineered it to. Yes, today's techniques, whether it's LLMs, whether it's reinforcement learning, use a lot of data, but there's no shortage of available data. And you are able to generate very, very accurate synthetic simulated environments, models, you name it. And so, yes, requires a lot of data. Never have we said, oh man, I wish we could just figure out how to generate more of it. There's not a shortage of problems, and there's not an access problem to the data. There are exciting things that are on the horizon. I think mentioned one-shot learning is something some other AI companies are focused on in terms of the next breakthrough, which is just a different way for an AI to learn. We'll see. I think we get really, really, really far today with RL, with LLMs, with even classical techniques that are not AI based. And that, again, I'm more focused on building the end product, the solution, than what is the tool that you're doing it with.
Now, I am actually curious for Colin and Brian, from a organizational standpoint, right? You are both in a position where you're overseeing the data for your organization. And I don't have enough familiarity with the Marine Corps and Coast Guard of what you're doing, so I'm kind of curious. I've seen it from the Navy of the challenges they've had, because it's, maybe at the tactical level, it's easier to get and generate data, but there's a lot of institutional data and things that I think organizations, especially that have been around for decades, are finding out this is a lot harder to actually get accessible and centralized and all the things you would like to be able to do.
Yeah, I mean, I think with plenty of unlimited funding, you're going to get access to that data. It's there. But you know, we expect that for many years we're going to be working with legacy systems. We got to figure out how to get access to our data with legacy systems, raise that data to a layer where we can then use applications to do whatever we want, analytics or some sort of an effect from it. We're working through that. There are different layers of you know, data that's really high quality. There's some that's low quality. And we're using kind of a use case basis where we prioritize based on what's important to the organization. We're not necessarily going to go after all the data at once. There will be data that sits there for many years and untouched, and it's just going to be there. You know, so.
From a Marine Corps perspective, we're deep in that right now. We're deep in understanding the tool, understanding how the tool works, from pulling data and pushing data from one source to another source to be able to capture and then analyze that data and push that data forward to another user. So we're deep in that. We have all the data we need. We understand that we have a lot of data, and it's how we access the data and how we curate the data is really on top of our efforts. And we're very deep in that process.
All right. I think we have time for one more question, sir.
Oh, goodness. I don't know if mine's going to be that riveting. Jason, too, from Leidos. I spent 20 years in the Navy, part of that time as a KO. So I really appreciate the comment regarding the acquisition process. Across the DoD, this is a multi-pronged problem. And while over the last 20 years, we brought in rapid prototyping, OTAs, MTAs, and all that kind of stuff, one of my junior tours way back when at NAVC, we were trying to lean out the acquisition strategy problem, right? And we're still not quite there, as you mentioned, in the commercial side. I spent time at Amazon and now Leidos. We operate completely different, right? So the question is the DoD still too siloed to really get after this problem and solve it? Thank you for your time.
Yeah, I think you see tons of different silos in DoD. Every program manager, every PEO has their thing, and that's what they want to focus on. And you can, you know, it looks nice as a collection of capabilities. When you zoom out, you're like, oh, okay, I can see how it all plays together, but they're not really in sync. There are pockets of success. I just want to be super clear. Like, there are wins with different PEOs, with different program managers, but you know, it's very siloed still. And not just actually from the PEOs, but also to the combatant commands and to the services, right? We're talking to one admiral. He goes, turned to his N9, his N9 asked him, he's like, hey, sir, how many of these MQ-35s do you think you're getting? He's like, well, I hope I'm getting 1,000. He's like, you're getting 54. He's like, what? And right, it's that disconnect in terms of where, you know, the problem, even on the COCOMs, back to the service providers, back to the PEOs, back to Congress and the budget. It's very much siloed.
The answer to your question is yes.
It's yes, but. It's yes, but I think this, and I said it earlier, that there's a lot of opportunities that we're seeing with this new capability. And from what I'm seeing within the Marine Corps, that the Marine Corps is really leaning in a lot from all echelons. I see it from the edge, from strategically. We're leaning into how we want to become data-centric. And that is something that, you know, makes me excited about getting up and doing this job today, is that Marines now are leaning in and they want this and they want to be a part of this.
All right, so acquisitions, and it's all about the data. All right, we're over time, so join me in thanking the panelists here for this great discussion. Really appreciate it. Thank you for your time.